So we were discussing about CAD cam, right? So we discussed about CAD and we discussed about cam right yesterday in the previous class.
Yes, sir.
So today we will move on to the CAD cam and automation. So can anyone tell why you need automation?
So can you repeat the question, sir?
Can you tell me why you need automation? Automation.
So automation is like basically because humans can make mistake, but automation is like you program the computers, they learn and they do the correct step and they do it continuously. Whereas you can only perform the same task like for 3 hours, assume, but robots can do it for 24 hours. And
Good.
they have feedback system. So even if they do any error, the system like again and again informs that like this much is error, so they correct with respect to that.
Okay, good Sachin. If you go for that is rapid prototyping or if you go for CNC machines, okay, all those are automation. So we will program to the machine so that the machine will process according to our programming. So the main advantage is okay to reduce the production of the what you can say the products that it will reduce the time and it will and it will increase the accuracy of the accuracy that is tolerance of the product. So for this purpose we want the automation. So in this you can see CAD CAM and automation. So this tells us we want CAD that is design and we want to write the programming for the for the machines so that by using this automation we can finish the task okay very easily with and we can reduce the given time for production of the products as well as we can get the accuracy of the product. So that is tolerance of the product. So this is what okay you will be studying about this slide. So you can see automation is the technology concerned with the application of complex mechanical, electrical, electronic, hydraulic, pneumatic, or computer-based system in the operations and control of production. So mainly the automation is required okay to control the production. So for this purpose okay we want this automation. So we will feed the programming for the like if you go for robotics okay we want to write the program. If you want to go for to work on the CNC machines we want to write the programming okay everywhere you want to write the program. Okay, now you can use it. Now you can use the Python for writing the program. So everywhere we want to feed the program for the machines. So according to the programming, the machines works. Okay, so that is called as automation. So automation in every field. If you go for mechanical, electrical, electronic, okay, and hydraulic, pneumatic, everywhere, okay, you want to write the programs. According to that, the machines will work. Okay, so types of manufacturing you can see there will be continuous process industries like manufacturing of sugar as well as the chemical industries. So it will come under the continuous process industries and mass production industries like your automobiles, your vehicles, okay, and consumer goods. Next, it will come for batch production industries, okay, so like machines and aircrafts. So this is called as batch. So if you take CNC machines or any machines, okay, so they'll produce it like a batch, like 1 month, 1 month. So this is a demand, okay, in the industry like 20 or 30. So they'll manufacture 30 machines and they'll supply for the customers. But if you go for automobile, okay, we cannot predict. So 1 month it may go to 50,000 okay buyers, that is customers. In another month okay it can go for 30,000. So that's called as mass production. That is mass production industries. Next, job production industries in this prototypes, heat exchangers, chemical reactors, all this comes under the job production industries. Okay, regarding to the demand, okay, we will produce the products and we will supply it to the customers. So these are the four different you can see like in the manufacturing that is continuous, mass, batch, and job. Okay. Next, if you go for automation, is focused on reducing the unit production time. So I told you. So this is very important. That is for producing the one product. So how much time it will take? So okay, by automation we can reduce the time to produce the product. So that is the main important. Okay, in the automation. Next, and to some extent time as associated with planning and setting up for each batch of production. So by writing the programming okay we can plan. So if example I told you right for manufacturing of one part, if it required around 5 to 6 machines, then we can plan. Okay, so this is the time taken for first machine. So for second machine what is the ideal time, right? Well, what is the ideal time? So what should be the ideal time so that it can go for the second mission, next third mission, fourth mission, like that. Okay, I think you learned about sequencing in the OR. Same way, okay, we can plan and we can schedule the schedule according to the planning. And setting time is nothing but setting the operation. So that is called as ideal time. So for from one mission to second mission, so how much time is required? So what is the ideal time? So setting time is nothing but in how much time it can finish the operations. Okay, that is called setting time. Setting up with a to time. So for one mission 2 minutes, second mission 3 minutes, third mission 5 minutes. So for how much time that it can complete the task, okay, in that particular mission. So all these things, okay, we can calculate, we can plan, and we can do in the automation process. Okay, so in the last point you can see CAD CAM is focused on reducing the time for designing the product and all other activities which are accomplished once for each product, and time associated with planning and setting up for each batch of production. So be careful, CAD CAM is very important, okay, in the right now. Okay, if you go for any industry, okay, they're using the CAD CAM. Okay, CAD with respect to designing the product. CAM is used for that is computer manufacturing. Okay, they will see everything in virtual. Okay, they will manufacture virtually. They will calculate all other activities like how to reduce the time. So what should be the inputs which we can give for the machines to complete the task. Okay, then what should be the schedule, like from first mission to second mission? Okay, how much time is the ideal time? Everything, okay, we can calculate virtually now by using the virtual machines. Then according to the inputs what we will get in virtual, we can implement, or we can implement all those inputs, okay, in real manufacturing system. So this is why you want CAD CAM. So as a mechanical engineer, you want to know about the CAD CAM softwares. Okay, so I told you yesterday also. Okay, so there are a lot of softwares are coming now. Okay, with us by using the computers. Okay, right now you are using a design that CATIA, ProE, Abacus, sorry, CATIA, ProE, then Unigraphics. All these are used for designing. So when you come for analysis, okay, then it will come for there are a lot of softwares are there, Abacus, Nastran, Pattern. Okay, for programming, I think you studied in the fifth semester sim, that is computer integrated manufacturing. In that, I think you learnt about the software Fanuc, right? Fanuc or what? Which software did you
The
learn?
Fanuc was for CNC machines. Okay, and sim only, sir. Correct, sir.
So that's only Fanuc. I think Fanuc you have
Fanuc OIT, sir.
Fanuc OIT, right? Okay, this is a software which you used in the sim lab. That's for manufacturing of the product. So all the softwares, okay, you will use because to reduce the time, okay, and to see whether the design is okay or not, to perform the analysis with respect to the design. Then you can know whether this design can sustain the load, or this design is focused on functioning with respect to the customer needs. So everything we will analyze. Okay, then all the inputs, okay, what we will get in virtually, we will implement in a real manufacturing plant. So this is a difference between the virtual manufacturing plant and real manufacturing plant. First, we will see everything in virtual right now. Then we will implement all the inputs in the real manufacturing system. If you go for MNC companies, they will follow all this process. Okay, so only there's a lot of vacancies are there right now. Right now, if you go for industry, MNC in this mechanical industry, there are a lot of vacancies are there with respect to Python, with respect to the analysis. Okay, everything. Okay, you have a lot of jobs. Next, we'll go for next slide. Okay, CAD CAM. So this slide, this style tells us, okay, what is the need? Okay, for what purpose you should use the CAD CAM softwares. So if you see the first point, CAD CAM, key to improve manufacturing productivity and the best approach for meeting the critical design requirements. So I told you. So we will see the conceptual design. Then from conceptual design, it will go for we will use some softwares, okay, CATIA or whatever it may be, and we will convert it into 3D image or 3D design. Okay, then we will try to improve the if the design is not okay with respect to the customers, then we should try to improve, okay, the design. So that we can do in CAD. Okay, then CAD/CAM software provides engineers with the tools needed to perform their technical jobs efficiently and free them from the means tedious and time-consuming tasks that requires little or no technical expertise. So this is what, by using the softwares, by using these tools, okay, we can perform the way we can perform we can what you can say, we can design the model, okay, then we can perform the analysis and we can see, okay, whether this design is okay with respect to the customers, this design can sustain the load according to the customer needs, according whatever they are given the customers, whether this design is meeting the needs of the customers, everything, okay, we can perform with the softwares, okay, so that the time will be consuming will be less. So within less time we can design the model, we can do the analysis, and we can see so what's happening. So once you go for real manufacturing plant, okay, it will take more time to manufacture the product, to do the test, and to find results. Okay, it will take around 6 to 8 months. If you go for steam turbine blades or wind turbine blades, okay, there you need for manufacturing of a one steam turbine blade only, it will take around 1 month or 1.5 months. So for manufacturing the steam turbine blades, 3 or 4, then to what execute or to manufacture that, after that, okay, they should do the testing. So for the test, again they should plant, okay, in one particular area, then they should test. For this all process, okay, it will take around 6 to 8 months. So this is regarding to real manufacturing system. So if you go for virtual, okay, you can do all these things within, I think, within 1 week or 2 weeks. So depending upon, okay, the design part, what you will do, and what you do the analysis within 2 minutes, within 2 weeks, you can complete the task. Okay, and you can say, okay, this wind turbine blades, okay, this is good for according to the customer needs. Within 2 weeks, then you can go for manufacturing. So once you've done the manufacturing, okay, after 6 months, if you know, if you got the result that the design of the blade is not good, okay, so it can get failure within 6 months due to the fatigue. Okay, if you got the information after 6 months, after manufacturing the design, then all the investment money, in invested money, and the time, everything will be wasted. So that first we should check virtually everything, then we should go for implementation. Okay, implementation in the real manufacturing system. Then CAD/CAM software speeds the design process, therefore increasing the productivity, innovation, and creativity of designers. So I told you always, okay, you should be creative. According to the customer needs, okay, you should give a design differently. So if you see the vehicle design, okay, your different vehicles, two wheel vehicles, okay. So you can see like Apache, Avenger, all these things, okay, all these things have different designs, okay. Why? Because of the creativity. So if you have creativity, you can give a better design product for the society, okay. So depending upon the customer needs, the customer will ask the needs. So according to that, we should get the inputs. Okay, we should get the data that is called as data analysis. We should get the data inputs. Then we should go for visualization. Okay, then we should go for the creativity. By your creativity, if you are more creative, you can give better product for society. Okay, so that you studied in the design thinking 1 and 2. Okay, that's creativity and as well as innovation. So innovation and creativity are both are very very important for mechanical engineers who are working in product design engineer. Okay, then last is CAD/CAM is the only mean to meet the new technological design and production requirements of increased accuracy and uniformity. So I told you, so to increase the productivity, okay, according to the customer needs, and to give a better product for society with more technical designs. So we need the softwares like CAD/CAM, okay, to reduce the time, to give better product for society with respect to the technical design. Okay, and the main thing is, okay, to increase the accuracy of the product. That is your quality or the tolerance. Everything will come under the accuracy. Okay, so and uniformity. So for this purpose, you want this CAD/CAM softwares. Then we'll go for the conventional product design and development process or development cycle. I think students, if you have any doubts in the previous two slides, you can ask me. Then I'll go for the next slide. Any doubts?
No doubt, sir.
Okay. So then we'll go for this slide. This and next slide is very important. Kindly try to understand these two slides. So this conventional product design and development cycle. Okay. The industries were following before, I think 20 years back, but right now they're following this product design development cycle with companies. So we will see first this one. So first, the main thing is, you can see first is, you can see the conceptual design at the top, right? So this is conceptual design. See, first the feedback will come from the customers. You can see at the end. So there's a feedback. See, packaging and shipping, marketing. Okay, once you do the marketing of your product, then you will get the feedback from the system. Sorry, feedback from the customers. Okay, then from the feedback again, you should go for conceptual design. Conceptual design is nothing but, once you got the information that your product design is not good, or your product, or because if the customer says, okay, you should increase the design of the, or you should change the design of the product, then it will come to conceptual design. Okay, so according to the market need or demand of the product, okay, you should analyze. Okay, then you should go for conceptual design or idea generation. So once you do the conceptual design, okay, that by using the brainstorming session I told you, so this comes under design thinking process. Okay, the first, from market design, for market analysis or demand, to the conceptual design to idea generation. Okay, it will take from design thinking process to the product design engineer. So first, the design thinkers will get the feedback, okay, from the customers regarding to the what you can say, the design thinkers. They will give you all the inputs for the product design engineer. The product design engineer will go for conceptual design. I told you there will be technical and non-technical design thinkers. The technical design thinkers will get the information from design thinkers, from non-technical design thinkers. Okay, then they will draw a conceptual design with respect to those inputs. Then that design, okay, the design thinkers will give for product design engineer. Then it will come for, then you should see this conceptual design. Now the conceptual design, the actual conceptual design will be done by the product design engineer. Then here, then at the top you can see conceptual evaluation and feasibility study for concept evaluation. After getting the idea generation, okay, then we will go for manufacturing the prototype, a small prototype. I told you. Okay, we will reduce the scale factor, and we will try to manufacture the prototype. We will test, and according to the results, what we get, okay, we will go for, and we will try to finalize the final product concept. You can see here, final product concept. So before this, we will go for conceptual design. Okay, we will at least we will try to get 3 to 4 ideas, 3 to 4 better ideas. Okay, then we will convert one by one the ideas in the form of the prototype. Okay, after prototype, okay, we will test that prototype. Okay, if it is okay, if the designs is okay with all the conditions, if all in the company, it's okay. If everyone agrees, top management people as well as the customers, then it will go for, then it will select, then that product will be finalized. That is called as final product concept. So that will finalize. Then it will go for product design and detailing. Okay, I think in second module we have seen, right, everything from conceptual to the final stage, right, students?
Yes, sir.
So those process will come under this product design and detailing. Okay, so we'll see about the product. Once that design is okay, once that final product concept is okay, then it will come for the detailed design. Okay, then they will see that product design, and they will go for detailing. So detailing is nothing but converting your final design to 2D model. Okay, 2D this one. Then it will go for production plan, the production drawing and technical instructions. So see here, after once you finalize that design, okay, that design, then we will convert into the 2D drawings. Then the 2D drawings will be sent to the production department. You can see here production drawings and technical illustration. After that, you can see production drawings and technical illustration. After this, you can go for design new tools, machines, and jigs. See, for that design, okay, if you do not have any tools, okay, that is your fixtures or jigs are not there, then we will try to design that fixtures as well as jigs. Okay, for the design, what you have done, okay, if you do not have any tools to manufacture that part or that design, then we should go for designing new tools, machines, and jigs or fixtures. If you want new machines, okay, if you want new tools, if you want new jigs and fixtures, so all these things, okay, we will plan. After this, here other materials, tools, machines, and fixtures, If you want other tools, after doing the first process, that is design new tools, machines and jigsaws or fixtures, if you want other materials.
So is it other or order, sir?
I think this order. Okay, order materials. That is your your raw materials. Okay, so we will go for ordering the raw materials. So you require raw materials to manufacture the products, right? So it will go for order materials, tools, machines, and jigs and fixtures. Then it will come for the production planning and scheduling control. Okay, these things So we will try to planning for manufacturing the products. After this, it will go for you can see it will go for actual the production. So after this process, some design new tools to the production planning and scheduling control. If it is over, then it will come for actual production. Actual production is nothing but manufacturing in the plant. Okay, after this, it will go for inspection and quality control. Okay, so whatever we are given in the 2D drawings, the dimensions, everything, okay, which will manufacture in the plant, okay, it should be accurate. So whatever we mentioned in the 2D drawings, if you manufacture the product, okay, it should be same. So that is called as, okay, standard reference. Okay, we should take the 2D drawings and we should check whether my product is functioning with respect to the drawings. Then we should go for inspection and quality control. After this inspection, we'll go for packing and shipping. So we should send for customers, right? Once the quality check is over, as well as inspection is over, so we'll pack the raw material. Sorry, we'll pack the product, and uh, we'll send for the marketing. Okay, or we'll send for the customers. After this, we'll market the product. Then we will take the feedback again. If the design is not good, according to the customer, I'm telling you, according to the customers, if they tell some inputs for you regarding to the design, regarding to the material, regarding to the quality, everything, okay, if they tell, we'll get the feedback from the design thinkers. Again it will come for the first, that is customer, sorry, again it will come for conceptual design. So again this process will continue. This process will continue uh, till it meets the customer requirements or customer needs. So this is about conventional. So this was used in earlier 1970s, 90s, 1980s. Okay, the same process they were using. So initially you can see there is no computers, right? Here there were no computers. Only, okay, practically they were doing, means practically they were trying to develop the prototype initially, and they were testing. So there were a lot of, you can say, the raw materials were wasted, the time was wasted. Okay, everything. Okay, they were wasting in the initial stage. I think everyone has understood, right? This
Yes,
process.
sir.
So here there's no computers. Only they were doing practically. Okay. So once the design is okay with respect to all the customers, as well as the what you can say, the company, its CEO, then immediately it was going to manufacture the small prototype according to the scale. Okay, scale factor, they were manufacturing this small prototype and they were testing. So the material waste was wasted. Okay, if the design is not good, then the material will be wasted. The time, okay, which is given for that is wasted. Everything will be wasted. Okay, the time as well as money, then the material, everything will be wasted in the conventional production design. In same, see, it is similar to here also. See, if you take design, new tools, machines and jigsaw fixtures. So if some error was there, okay, while manufacturing a tool, okay, or if you take some other machines, okay, or jigsaws and fixtures which you manufacture according to the need to manufacture the part or product. Okay, it was some like if you take the tolerance was not okay, okay, with the fixtures, then again that material is wasted. Then time to manufacturing the jigs is wasted. Everything was wasted in the conventional product design. Okay, so initially whatever you take designs, whatever you take decision, okay, it should be pakka, it should be 100% okay. Then only, okay, you should go for manufacturing the product, or you can go for the finalize the product concept, or you can go for the taking the new tools, or buying the machines, or manufacturing the jigs and fixtures, everything. Okay, you should do the first time and 100%. Okay, if you do not complete the task accurately, then the time, money, material will be wasted. Okay, so only now you can see the next process, that is product design and development cycle with computers. So right now everything, so from the conceptual design to the marketing, or the conceptual design to the inspection, everything is uh, everything we are using the computers, okay, to see whether we are getting accurately. Okay, we will get all the inputs, okay, in the computers first. Okay, that is called as virtual manufacturing. So we'll get all the inputs from the virtual manufacturing in the computers. Then we will implement all those inputs in the real manufacturing system, and we'll get the product. Okay, that's accurately. So you can see here. So that's feedback. You can see feedback. Then it will go for the market needs or demand. Then you can see here conceptual design and idea generation. So invention machine. So you can see here, okay, this and all, okay, we will analyze with respect to the we will analyze it with respect to the computers, because we will, once you do the conceptual design, okay, then then by using the design team, okay, we will convert the conceptual design to 3D drawings, right? So right, students, so all these things, from conceptual design to the final product concept, okay, we will use the computers. You can see here conceptual evaluation and feasibility study for concept evaluations. Then CA analysis, handling database. What do you mean by CA, students?
So is it computer aided analysis, sir?
It's good, computer aided analysis. So we will do the computer aided analysis everywhere. So for design, once you've done the conceptual design, we'll convert that conceptual design to the 3D drawings first. Okay, that is a 3D view by using the softwares, and we will do the analysis. We'll apply the boundary conditions, and we will see whether the material can sustain the load or not according to the conditions. Okay, so all these things we will see initially. Okay, then we will finalize the product. We'll finalize the product concept, final product concept. Okay, that is your design. So we will draw. We'll at least we will take around 100 conceptual design. Then select best three designs. Okay, best three design. Then it will go for C analysis. Okay, we will try to design the 3D model. We'll apply the boundary conditions, and we'll find the results. Then within the three, which design is best according to the customer needs and the satisfaction of the other department heads. Okay, we'll finalize that concept. Then it will go for the real, or you can say the virtual manufacturing system. It will go for the virtual. Then you can see here computer design arcade. See, geometrical mathematical modeling. We will go for analyzing. Okay, we will we will convert your concepts into reality. That is geometrical and modeling, mathematical modeling. Then you can see computer design. Computer design, it will come for geometrical mathematical modeling. Then simulation. Okay, that is if you take the IC engine. So for individual part, you can do the simulation, or you can do for car also, like crash analysis. So see, individual part you can do analysis, as well as you should do the analysis for overall the product, or overall the assembled product. You can do for sub assembly part as well as assembly part. So depending upon the demand. So if the customer is asking do analysis for IC engine, so we should do analysis for IC engine, and we should say, so if the piston is moving around 7,000 RPM, okay, that is the revolution per minute. So what is the stress, okay, which is induced in the cylinder, okay, on the piston, everything you should analyze, and we should say. So we should do analysis for that. So we should say the material, whether the material can sustain that much, what we can say, the speed or not. Okay, whether the crack may be initiated inside the cylinder, whatever it may be. So we should give the results according to the application. So where you are doing. Okay, so simulation, for sub assemblies also you can do for overall assembly. That is your overall car. Okay, so that you can do the crash analysis or impact analysis. Okay, everything you can do in simulation, like see computer aided analysis, that is FEA, CFD. Okay, everything, okay, you can do in the means analysis software. Next, we can come here, computer drawing, see computer design, simulation, everything first we will see here. First, we will create the geometry, okay, and next we will go for the simulations, that is softwares. Once you got the information that this design is safe according to the customer needs. Then it will come for this here computed design, sorry, computed drafting. So here what we will do, once that design is finalized, then we will go for drafting. That is, we'll convert the finalized design to 2D drawings. You can see here. So that is called as computed drafting. So the production, the assembly drawing, and technical illustration. So you can see here, once that product is finalized according to the needs of the customers, everything is okay. That is, if you done analysis, okay, after analysis you got the information that okay, according to the customer needs, okay, you are applied the boundary conditions, and you got information that the material is safe, or the car is safe, whatever it may be, depending upon the different applications. Then we'll go for final drafting. That's completed drafting. Then we will give all the drawings, technical drawings, the production assembly drawings for the next team. Okay, that is your manufacturing team. That is computer aided manufacturing. Okay, this also we will first will see and we will analyze with respect to the computer. You can see here computer aided process planning. So next will come for computer aided process planning. In process planning, we will see, okay, so what will happen? So if you take this machine, okay, if you design the fixtures like this, okay, and if you take these tools, so what will happen? This is not practical. I'm not telling real manufacturing system. I'm telling you in virtual manufacturing. Okay, that is, we will create the machines. Okay, and we will take when we will manufacture the jigs. Okay, in the virtual manufacturing, and we will try to analyze. So what will happen? Okay, in virtually. So that is called as process planning. So we will be trying to analyze to manufacture the product. So what are the machines are required? So what are the jigs? What is the jigs, and what are the fixtures are used? So what should be the dimension? Okay, if I use these types of fixtures, so what will happen? So everything we will analyze in computers, not in the real manufacturing plant. You can see here computer tool, machines, and fixtures design. So everything we will see with respect to the virtual. And next you can see computer material planning and handling and ordering. So you can see ordering is nothing but the materials. Then we will see the planning according to the computers. That is, see, so if there are 10 missions are there, so we will see each mission how much time is required in virtual. So we will place the we will place the workpiece there, and we will see how much time is required to complete the task. So how much material are wasted, okay, and how much material is required. Everything we can analyze in computers first. That is virtual. Okay, to complete the task, to complete the product, that is planning. So how much time is required in one machine? So we will not go we will not go for directly for the real manufacturing system. We will see in virtual first. We will place the machines, okay, 10 machines examples, and we will see in each machines how much time is required. So we are placing the workpiece virtually, and we'll be trying to analyze how much materials are required, how much material will be wasted, how much time is required. Everything we will analyze virtually first. Then we will implement according to this virtual to the real world. Sorry, real manufacturing system. Then you can see computed the production planning and scheduling. So whatever I told you now, okay, it's similar. If there are 10 manufacturing manufacture, if you want manufacturing machines, so how much time is required? So about planning, okay, from 1 to 1, how much time is ideal? Everything you can analyze here, and you can see at the end computer controlled robots and other devices. So if you want robots, example, okay, if you're using robots in your application to pick and place the raw materials, right now in future in next another 2 to 3 years, okay, in if you go for any manufacturing plant, okay, there'll be robots will be there. Okay, the robot job is to pick and place the work pieces. Okay, so according to the whatever we mentioned, okay, it will do the job. So right now, so that is done by humans. Okay, in future, in at least 3 years, okay, everywhere in the MNCs companies, okay, the robots will be replaced. Okay, to pick and place the raw materials. Okay, so all these things, okay, we will see virtually first. I think everyone is understanding, right?
Yes, sir.
So here you can see computer process planning. In down you can see computer part programming. So to complete the task. Okay. So the left hand side views that what type of machines you require, what type of fixtures you want, yeah, and what is the time required to finish the operations. Everything, okay, it is done in it is given in this part. But in the right hand side, after computer process planning, you can see completed part programming and CNC programming. So this indicates to complete the task, you want to write the programs, right? To finish the task of your product. So you want to write the programming. So without writing the programming, for each part. So if there are 10 parts are there in assembly, if you take this part, if you take the what you can say, your simple thing is your screw jack. Okay, what you done in the first semester, or if you go for AC engine. So first you should write the programming to manufacture each part. Okay, then you can go for assembly, right? So then you should write the CNC program for each individual parts. So that's called as computed part programming. Part means for individual part you should write the programming, so that it will see example. If you want to produce this one IC engines, okay, so there will be 10 parts. This example, there if there are 10 parts, you will be having 10 machines, right? So in one machine, one part will be done. In second machine, another part will be done. So like that, for each machine you should write the program, that is CNC program for producing each part. So this indicates computed part programming. For each individual part you should write the CNC programming, then only you will get the product, right? So right, students.
Yes, sir.
So we will analyze everything here. So once you got pakka, so there is no time, there is no time will be wasted. So we will control the time. Okay, we will control the wastage of the raw materials. Okay, everything, and the planning of the production of the parts. If the customer is asking around 100 products, 100 IC engines, okay, within 2 days, then we will plan. Okay, how much machines are required. So for if you use 10 machines for one day, so how much product we can manufacture, everything we can analyze here virtually. Then we will go for the actual production. Here you can see at the end. Okay, after analyzing all these things in computers virtually, then we will go for actual production. So in actual production, it will go for inspection and the quality control. After production of the products, we will check the accuracy, that is tolerance, quality, everything we will check. If it is okay, okay. So here also you can see with respect to the computer aided quality control as well as computer aided packaging and shipping. So right now after production, after doing the production in the virtually, okay, you can see the quality as well as the tolerance. Okay, so after seeing in virtual, then you can see in the real manufacturing system also. So you will follow all these inputs which are given by the virtual. Then we will implement those inputs in the real manufacturing system. Okay, then it will go for inspection, quality control. Here also we will check the quality control, then packaging and shipping. Then it will go for sales and marketing. Okay, sales and marketing. So then feedback. See, right now what I'm told you, the data analysis. Okay, so all these things. Okay, I think yesterday I told you about data analysis, right, students? Data
Yes, sir.
storage. So data collection and data storage indicate the feedback. So all this data we can store in computer aided marketing and database handling. So you can see here. So right now everything we can store. That is whatever the customer is giving the feedback, everything will be stored. Okay, in the computer analysis aided marketing and database handling. Everything will be stored there. So if you want before 10 years back the feedback, then immediately if you write the date, whatever it may be, okay, the software will give the results. That is, this was the feedback by the customers. So everything, okay, we can store in the computer. Then again regarding to the feedback of the customers, okay, the design thinking team will get the feedback. Again it will go for the market, sorry, again it will go for the conceptual design according to the customer needs. I think everyone has understood, right?
Yes, sir.
You see here, your fifth module indicates from the conceptual design. Okay, what you're using the virtual from your CNC programming, everything. Okay, you'll be studying in the fifth module. Only the fifth module indicates the virtual. I think everyone has understood it. Fifth module indicates only virtual. So what you will be doing in virtual? So what type of machines, like rapid prototyping machine, or you can go for the rapid prototyping only. It will come the 3D. That is your your CNC. Rapid prototyping means your 3D printing, CNC machines, everything. Okay, will come under this process. That is, you will see virtually first everything, then we will implement the virtual inputs to the real manufacturing systems, and we will complete our task. Okay. So right now in industry, okay, they're using this product design and development cycle with computers. So without computers, there is no what you can say, we cannot complete the task, or we cannot complete our product within the time. We cannot select the product whether this design is good or that design is good. So it is very very difficult. So only we will use the computers to analyze, okay, the designs, and next we will finalize. Okay, virtually we will do everything till manufacturing. Then all the inputs whatever we will get in virtual, we will implement through the real manufacturing system. So you should understand this. So once you go for industry, okay, maximum if you go for production or design, they will ask about these things. Okay. So you should analyze first this. Okay, then you should say the answers regarding to the virtual. Then all the inputs which will get in virtual will implement in the real manufacturing plant. So this is very important. Okay. Then product life cycle. I think anyone has any doubt in these two slides?
No,
The
sir.
the convection what they are doing. So in the system, that is the computers, the product design and development cycle with system or with computers. So you should understand these two. It's very important. Yeah, then we'll go for the product life cycle. So see, with this product life cycle is with respect to your virtual, that is indicates your virtual manufacturing system. Okay, how you can decide the life cycle of the product by using the softwares, that is CAD and CAM. So you can see the three main processes are design and manufacturing, right, students? For any product, you want to have design and you want to have the manufacturing, right?
Yes, sir.
So we'll use the softwares, that is virtual to design as well as virtual to manufacture. Then according to the inputs whatever we get in the virtual design and virtual manufacturing, so we will implement those inputs in the real manufacturing system and we'll complete the task. So everyone knows now. So virtual, first we will do everything in virtual, then we will implement the inputs what we got in the virtual to the real manufacturing plant or real manufacturing products. So you can see the two main processes are design plus manufacturing. Okay, so the two sub process of design is synthesis and analysis. So if you go for design, okay, so there are subdivision, right? Synthesis and analysis. So if you go for what is the synthesis, so synthesis is nothing but the conceptual design. Okay, so in synthesis what we will do, we will get the feedback from the customers, and whatever the customer needs, according to the customer needs, we will go for conceptual design. So this is nothing but your synthesis. And what is analysis? See, analysis is nothing but once you complete the conceptual design, then we will go for designing the product by using some softwares, and we will try to perform that. And I mean, perform is nothing but we will apply the boundary conditions according to the customer needs, and we will find the results. So synthesis is nothing but will conceptual design, and analysis is nothing but to get the results or to evaluate the performance of the expected product. See, whatever you designed the model in the softwares like design softwares, we will we will use that design of the product, and we will do the analysis, and we will see so what is happening in the design, whether due to fatigue the material is going to fail within 5 years or 4 years, due to the creep or due to the static analysis, whatever it may be. So we will conduct different types of analysis regarding to the application. So be careful. We cannot do fatigue for outside the body. Okay, means we cannot do the creep analysis. So fatigue you can do. We cannot do the creep analysis for the chassis because there will be no temperature change. Okay, in the chassis. So creep is used only for the temperature. Okay, if you keep on increasing the temperature, so what is the effect of that structure or for that body? So only you can do the static analysis or fatigue. Fatigue you can do because of the chassis will be moving. When the vehicle moves, okay, the chassis will be moving so that the load will be varying on the chassis. But if you take a vehicle which is not moving with the car is stationary, for that stationary product we cannot do the fatigue analysis because the vehicle is not moving. So there will be no different types of load will be acting on the chassis. Example I'm telling you. If you go for IC engine, you should do the creep analysis, you should do fatigue analysis, you should do static analysis. So all this is called as performance. So regarding to that performance, we should decide whether this design is okay or not. I think everyone is getting right.
Yes, sir.
So depending upon your applications, where you are finding. So if you go for automobile industry, if you tell do the analysis for the chassis, okay, you should not do for creep. Okay, you should do only for fatigue. So they will tell. Oh, so what? So what is the what you can say? What is the fluctuation load which is coming on the chassis? They will tell. So you should apply the load according to the customer given. So then you should find the fatigue life. So how much is the how much cycles does the chassis can sustain, like 20,000 cycles, 30,000 cycles, or 40,000 cycles. Okay, you should find those things, and finally you should tell, okay, this much is the year that the material can sustain, or the chassis can sustain. So all these things is called as performance. You should do the analysis and you should find its performance. So there will be two subdivision in the design, that is synthesis and analysis. Synthesis is nothing but only the conceptual design, and analysis is nothing but doing the analysis regarding to the customer needs and finding the performance of the product. I think everyone has understood, right?
Yes,
So,
sir.
regarding to the expected, so they will tell, the customer will tell. So I need the product which works for 15 years or which should work for 20 years. So depending upon the customer needs, okay, we should design the chassis. So that chassis should sustain for at least 18 years. So if he's asking 20 years, at least it should work for 18 years. So once you do the analysis, okay, you should tell this material or this chassis can work for 18 years. So that after 18 years, the crack may develop in the chassis. So that also you should tell where the chassis, where the crack will be developed in chassis. Okay, that also you should tell. So if you go for industry, you be careful. Everything you should do analysis and you should tell the results for the customers. So vendor after how much year, okay, the material, okay, can get failure, where the crack may be initiated. Okay, so when it reaches this much load, so the crack may initiated. So how the once the crack is initiated, how much time is required to failure. So everything you should tell to the customers. So this you will get with respect to experience. If you keep on doing the analysis, okay, then you will get the experience. Then according to the analysis, and once you see the practical experience, once you get the practical experience, okay, you can analyze and you can see the results. So this is very important. One is conceptual design. Once you convert that conceptual design to the real design means virtual design. Okay, virtually once you do the design, then you do the analysis virtual, and you should tell the results. What is the performance of your product? Whether the material can sustain that much year, whether the material cannot sustain that much year, where does the crack will be initiated? Okay, what is the fatigue life? Okay, what about the creep? What about the static analysis? Everything you should do the analysis and you should say the results. So that's called as performance. Next, you can see computer prototypes, less expensive and faster to generate. So why we are doing all this? Why you are doing virtual means because of less expensive. Because so there is no investment for the raw materials, right? So right, students, there's
Yes,
no
sir. No
investment.
investment for raw materials.
So there's no investment for raw materials. There's no investment for the machines. There's no investment for the testings. So there's no investment for anything. We will do only everything in the virtual and faster to generate. So to get the results, okay, it is faster. I told you, if you go for wind turbines, okay, to get the results for one design, it will take 6 to 8 months. So similar way, if you do in virtual, you can get in 2 weeks. So which is faster?
Virtuals.
So virtually is very faster. So only everyone, okay, first in the MNC companies, they will go for virtual. Okay, they will do virtual first, then they will implement. If everything is okay, from design to manufacturing, if everything is okay, all the inputs which is given in virtual is okay, which is generated good products, resulting good fatigue life, good creep, I mean good creep resistance, good static, whatever can that can sustain the static load. If everything is okay in designing, also it's okay. Okay, so there's no stress concentration, whatever it may be. If everything is okay in the virtual, then we'll implement all the inputs whatever we got in the virtual to the real manufacturing plant. We'll give all those inputs so that the employees will take those inputs and they'll convert the raw materials into the finished products. Okay, then we'll go for the CAD softwares. I think everyone knows, right? Whatever I told you, okay, it's written here. the CAD tools. So what are the requirements you want? So design tools plus computer. In computer, you can see there is a software and hardware. Hardware indicates central unit, display terminals, input or output devices. In software, you can see graphics card you want, modeling, applications, programming. So if you have these two, okay, then you can call that as CAD tools. Okay. Similarly, if you go for the manufacturing tools, that is CAMS tools. Okay, you can see manufacturing tools. You want manufacturing tools plus computer. That is software, hardware, and networking. So you say central unit, display the terminals, input or output devices. Then in software you can see the CAD database. That is your uh, what you converted the design. Okay, in the different format. Okay, to import that one. Okay, so you want the CAD database, then NC programming. Okay, you should write the programs so that should be saved, or CAP or MRP. So this is very important. Okay, you want this to convert from 3D drawings to import. Okay, sorry, to import the 3D drawings to the software. Like if you go for the simulation, okay, like analysis, then you should import the drawings. So you want the a CAD database. Okay, in NC for doing the CNC programming. So you want to store the NC programming. First, you want to save the NC programming. You write the program, you save that. Then you should import that programming in the software, simulation software like Fanuc. Then you can complete the task. Okay, and networking of robots, manufacturing cells, material handling system. So you want the networking. Okay, if you have these two, then it is called as CAM tools. Okay, this is what is CAD and CAM. Next, if you go for computer engineering, so I think everyone I told you number of times, computer engineering is nothing but doing the analysis. Okay, so you can see all the terms what I mentioned here, like CFD, thermal analysis, vibration analysis. Okay, FEM, that is linear, static, dynamic, and seismic analysis, non-linear static analysis, fatigue, creep. Okay, everything will come under FEA. And kinematics analysis and animation. I told you, kinematics is nothing but movement to find the velocity of the links, right? To find the what is the velocity, what is the forces which is acting on the pairs, kinematic pairs, everything. Okay, you can see in kinematic analysis and animation. I think everyone is getting right.
Yes, sir.
Then mechanical assembly testing, that is dimensional checking or interference checking. Next, mass property calculations to find the mass property. Okay, like mass of the product, center of gravity, moment of inertia. Okay, everything you have the software. Okay, you can see a CAD is a technology concerned with the use of computer systems to analyze CAD geometry, allowing the designers to simulate and study how the product will behave. So same. So whatever you complete the product, sorry, the design in the CAD softwares like CATIA, ProE, Unigraphics, whatever it may be. Use the software, you convert your conceptual design to the virtual design. Then the virtual design will be implemented in the analysis softwares like Abacus, Maston, Pattern, ANSYS. Okay, we'll import those design here. Why? To see what are the results. So if you want to see only if you want to do static analysis, go for linear static analysis. If you want to find the kinematic, what is the velocity of this kinematic link, okay, then you should go for kinematic analysis. So depending upon your applications, okay, what you want to find, so depending upon that, okay, you should use the software. If you want CFD, okay, you want to find the fluid analysis, you should do the fluid analysis, then you should go for computational fluid dynamics. Okay, you can use the CFD, that is ANSYS Fluent. ANSYS Fluent for doing this analysis, thermal analysis. Again, you can go for the ANSYS. Then vibration analysis, you can go for ANSYS. Okay, for nonlinear dynamic analysis, now then seismic analysis, everything you can go for the ANSYS. So I think everyone has got right. Depending upon your what you want to find, okay, for that particular product, select the software, go for analysis, do the analysis, get the results, and tell the results. So what is happening, what is not happening. If the design is good, then you can say, sorry, if the results is good according to the boundary conditions, you should say the design is good so that it can sustain the load, or it can the design is very good, so you can go for virtual manufacturing. Then it will go for virtual manufacturing here. This one, okay. First we will do everything, whatever you have. So first we will do here, then it will go for virtual. So right, students. So everything will
Yes,
come
sir.
at the right side
Sir,
end.
sir, sir, can we leave, sir? Like we have next class at 9:30, sir.
Okay, okay. So this completes, I think, the completed engineering. So tomorrow I will start a digital mockup. Okay. So digital
Okay,
mockup,
sir.
another I have another 8 to 9 slides. Okay. So data modeling. I'll finish within tomorrow. Tomorrow I think tomorrow I'll finish up this fifth module. Okay. So wait for 2 minutes. I will take the attendance.